Problem number 3. The diameter of a circle is 8 centimeters. A central angle of the circle intercepts an arc of 12 centimeters. What is the radian measure of the angle? So we're going to highlight the important information. We know the diameter is 8 centimeters. We know that the angle intercepts an arc of 12 centimeters, which is in reference to the arc length. And we're looking for the measure of the angle, but we want to make sure that it's in radians. So I know that the diameter is 8, which means that the radius is 4. I know that the arc length is 12. And since I'm dealing in radians, I know that there are 2 pi radians for a circle. I'm going to draw a quick picture of what this problem represents. So I have a circle, my center, 2 radii, which I know are both 4, intercepts the circle of an arc length of 12. So you do have the arc length formula, which you do have to know. And the arc length formula is arc length equals the angle, which in the picture is here, out of, since we're talking about radians, it's going to be 2 pi. If it was asking for degrees, we would use 360. But in this case, 2 pi for radians, times, and then our circumference, when we're talking about arc length is a part of the circumference. Area of a sector is part of the area, which means we use pi r squared. But in this case, arc length refers to the circumference, which is 2 pi r. So I'm going to plug in what I do know. I know that the arc length is 12. I'm looking for the angle out of 2 pi times 2 pi times the radius, which is 4. So we have 2 pi, which is in the denominator, 2 pi, which is in the numerator. So that means they'll simplify out to 1. So then that gives us 12 equals x times 8 . Alright, sorry, that should be x times 4, because 2 pi and 2 pi, we're going to simplify to 1. So then that gives us 12 equals 4x, and when you divide by 4, you get x equals 3. And with x equals 3, that means our answer is letter B. For problem number 4, there's 2 ways you can do it, by hand and by calculator. I'm going to show you by calculator first, and then I'll show you how to do it by hand. So in number 4, we're talking about a spherical ball, which is in reference to a sphere. And it told us that the total area, keyword area, is 36 square inches. And it asks us to find the maximum volume. So remember that on the Math 3 exam, it does not give you a formula sheet. However, though, on some of the problems, it will have a formula embedded into the problem for you to use. So since I'm looking at area is 36, that means I need to start with the area formula first. So I know that the area formula, or surface area, is 4 pi r squared. I know the surface area is 36. And I need to solve for the variable. So in order to solve for r squared, I'm going to divide by 4 pi. That gives me, go on to simplify, 36 divided by 4 is 9 over pi, which is r squared. And then in order to simplify the second power, I'm going to take the square root. And that gives me the radius, which I can now plug into my volume formula. So when I simplify this gives me r equals 1.7. I'm going to take that value and plug it into the volume formula. So that's going to be 4/3 pi 1.7 to the third. Make sure 4/3 does go in parentheses. But when you simplify this, you get 20.6 approximately. So for my volume, I got 20.6. As you can see, I plugged in all of my answer choices as they were. And the closest one to my answer was letter C. It's not going to be exact because the 1.7 was rounded. So just remember that if you round anytime throughout your problem, your answer is going to lose some accuracy. So it's not going to be exact, but it should be very close to the answer you have. So the correct answer, if you use the calculator to plug in instead of working that by hand, should be letter C. So now for those of you who are interested, I'm going to show you how to actually work it out by hand. So before we use the calculator, we got that the radius was 9 over the square root, we got the radius was the square root of 9 over pi. When you take the square root of a fraction, you can break that fraction up. So it would be the same thing as square root of 9 over the square root of pi. With the square root of 9, we can simplify to 3. But with the square root, you learned in Math 2 that a radical, like a square root, cube root, can be rewritten as a fractional exponent. So if I have the square root, that is the same thing as saying pi to the 1/2 power. So since I'm doing this by hand, I'm going to take that answer and plug it into my volume formula. So then that's going to give me 4/3 pi, and then 3 over pi to the 1/2 cubed. So I'm going to simplify the last parentheses. So that's going to give me 3 cubed, 27. And pi has an exponent of 1/2 that I'm raising to a power of 3. So when you raise from one exponent to another, you multiply. 1/2 times 3 is 3/2. So pi to the 3/2 times pi times 4/3. So then I'm going to simplify. 27 times 4/3, that gives me 36. And since I have pi, which is basically in the numerator, and pi to the 3/2 in the denominator, that means that I can divide them. So this is the same thing as saying pi to the 1st power minus 3/2, which gives us pi to the negative 1/2. And so then that simplifies to 36. Remember that when you have a negative exponent, it turns into a fraction. So pi to the 1/2 goes at the bottom. And just like before, here, when we did square root to pi to the 1/2, pi to the 1/2 is going to turn into the square root of pi. So my final answer would be 36 divided by the square root of pi, which is still letter C.